Okay, so we're recording that half of our TikToks are babies.
Yes.
Things that you need to know, like, are all of the integrals. Remember that I keep referring back to the study guide. Under topics, you can open the study guide. You might even want to print it out and put it in front of your notebook, because it's all in one place where you can look up, oh, I don't remember the mean value theorem, which would crop up in any homework on any test. Pretty much you need to start looking over that study guide before every test or quiz, because anything that I've taught before is fair game. If it comes up on the AP, I'll put it in. If it has something to do with a slope field or Euler's method, on an ABC part, write the equation with the tangent line, blah, blah, blah. The study guide's awesome. So it might be worth your time to print out. It takes you through all the AB topics, and there's like a line that's drawn and the BC topic. But it's really great to read over. It's very succinct. It's just the way I taught it to you. And so I'm a big fan of it. Okay, on page 385 are, I believe, all of the integrals you should know today. So on page 385, that's also there. As you're looking at the study guide, almost all, there's a few more that you'll learn, but we're pretty much at a place where we're memorizing integrals based on the fact that somebody integrated at one time. Somebody took a derivative and they got secant. Like when their teacher, or back when they were being tutored hundreds of years ago, if you were actually taking the derivative of this, and you knew to take the derivative actually based on, let's see what I would do here. Probably something Rose saw at Vandy in the Cal 2 class you went to, which we'll learn soon. L'Hopital's rule, which made me laugh because Anna and Elena already know L'Hopital's rule in a different form. But anyway, it was really encouraging to her to be sitting there. Was it Vandy?
Yeah.
And the Cal 2 class.
Yeah.
I wish, and actually what would have been a little cooler is it doesn't really matter when I teach L'Hopital's Euler's method integration by parts. It's kind of like we're in pre-cal mode right now, where I can teach sequences and series or rational functions, just pick a topic. It'd been kind of cool if I just happened to have picked L'Hopital's rule before I picked Euler's method, then she'd know what she was, she would be well used to what was going on in the class. Anyway, one thing you don't know yet that people have started to realize is if I say integrate logarithm, you don't know how to do that yet. It's my hope and prayer that you actually know how to take the derivative of a logarithm, but I don't think that's happened yet. In my dreams it's happened, but I don't think it's happened really with exponents and logarithms. I don't really know what else to do about it. I'm just going to continue to write them on the board and give them to you. Anyway, to take the derivative of a logarithm, you say 1 over u if you're taking a derivative. While you're down there, you say ln of the base. With a logarithm, you put it underneath. And then the derivative of sine is cosine. You're using the chain rule. Don't forget the chain rule. The derivative of ln u is 1 over u times ln of the base, derivative of u. Ln e is 1. The reason I keep writing it down there is if this was a logarithm to base 2, there need to be an ln 2 down there. So we can't get lazy about it. When we get the pleasure of seeing ln's and e's, those derivatives are shorter because ln e is 1. But if we don't have base e, then we've got to have that extra ln 3, ln 2, or whatever the base is. Alright, so anyway, ln e is 1, and you go cosine over sine, and you go, oh wait, that's cotangent. Do y'all see what I mean? Okay, so now somebody remembers, oh, I can take the antiderivative of cotangent now. It'd be ln sine x. Do y'all see what I mean?
Yeah.
So if you realize you've taken a derivative and gotten that, then you go backwards. What's happened so far is you haven't taken a derivative and gotten logarithm. Or if you have, you just didn't notice it in your notebook, right? So you can't go backwards until you've noticed it, or unless you can unthink it. But we'll learn it soon. But anyway, all of these are on page 385. Let's see if there's something else I want to say. Okay, so let me take questions on 367. No, those are
379.
379. Okay, questions. I heard some going around, but I don't know what they are. All right, Grace.
I have a question, a different thing.
Okay, we're only right now on homework for last night, but don't forget your other question. All right, homework for last night. Caroline?
Can we do y equal number 53?
53. All right, so you have y equals x arc cosine x, as I'm writing it down, I know that I'm gonna have to use the product rule here. Minus 2 times the square root of 1 minus x squared, where I'm gonna have to use the chain rule. You gotta be on your toes, ready all the time for the mundane product rule, quotient rule, chain rule, because they'll grab you if you're not watching for them. Alright, so you're gonna say first times derivative of the second plus, let's get rid of him.
Bye-bye.
Alright, plus the second times derivative of the first. I'm just doing the derivative of this right now. Girls, I strongly recommend what I just did. You know why I just did that? Because I'll get halfway through the product rule and forget to finish it. I'll be all intent on the derivative of arc cosine x, and I'll forget to ever go back and do it the other way. So I don't know if you've noticed when I'm doing product and chain, I write the whole thing out. I'll go low, d high, and leave that blank, minus high, d low, and leave that blank over low squared. So anyway, first times derivative of the second plus second times derivative of the first. I highly recommend that. Alright, then I'm going to go into this back part. This is 2 times 1 minus x squared to the 1/2 power. So if I bring that down, that's going to give me 1 times 1 minus x squared to the negative 1/2 times negative 2x. The reason I went ahead and did that is I myself can get so caught up in the product rule I forget to finish the problem, or some of y'all even like copy down the problem without actually doing any calculus to it. A few people did that on the most recent test. I was like, take this integral, and they didn't. They just filled numbers into the x and went over x or whatever. So anyway, that's just a suggestion. Let's keep moving. You're memorizing the derivative of inverse cosine now would be negative 1 over the square root of 1 minus u squared, and then du is 1. Let me pause and see if you have any question about that. You just have to memorize it.
Oh, yeah.
All right?
Should there be a negative before the 1 minus?
Oh, is that a, is that a minus?
Yeah, that's a minus.
Okay. Thanks.
Sorry.
So that's a minus. Okay. Then I'm going to say plus second times derivative of the first. And then I have this derivative right here. Okay, so now I'm going to follow my rules for cleaning up a derivative, which are negative exponent common denominator factor. Negative exponent common denominator factor. Okay? So I'm always refraining from multiplying things out too much, which isn't really going to come up here. This gives me negative 2x over the square root of 1 minus x squared. Is that arc cosine 2?
No,
2
arc cosine x.
That's 2 arc cosine. It's arc.
Oh, okay. I didn't see my x. I was wondering what in the world I wrote there. So it says 2 arc cosine x, and then this is minus a negative or plus 2x over the square root of 1 minus x squared. So I would, I'm a strong proponent for just being very, very literal. I told you take care of negative exponents. Get a common denominator factor, but I don't even have to do all of that here because what happens to the front and the back? Cancels out. And I guess the answer on 53, I hope, was 2 arc cosine x. Okay. But it really taxes you on the chain rule, the product rule, the quotient rule. All of those rules are not going away. So you have to get good at them. Okay, Anna, did you have a different question?
Yeah, can we do 57?
All right, so this is 57. All right, so 57. Where 57? All right, so I have x arc sine x plus the square root of 1 minus x squared.
Yeah.
All right, and just pause for a minute. If you had to integrate that, that would be very, very difficult for you right now. You would eventually be able to do that, okay? But even part of it still borders on, you know, things that some other people couldn't make it through. You'll be able to. But do you see why I say, but also we could have one that we couldn't take the antiderivative of. Like this. This is hard to take the antiderivative of. In fact, you couldn't. Because it's a composite function. I don't know if you can see that, Sophia. I'm sorry. It's the sine of x squared. Like you have no business like trying to make that sine cubed over 3 because do you see you haven't dealt with the sine yet? which is definitely affecting the motion of this. Would y'all agree the sine and the squared? So that it's a derivative, it's a slope, it's how something's changing. You would have to compensate for both of those. So I may go back and do this one later today. But this one, nobody's ever actually found the integral of that. I keep mentioning that one, okay? So I mean, that's a calculator active problem. But my point is, I can take the integral of it. I can take the definite integral of it with my calculator. But I can't take the antiderivative of it. So do you see why Mr. Walters and I have that joking war going on? An integral is not an antiderivative. The fundamental theorem of calculus is that they found out, oh my gosh, if I can take the antiderivative, I'll get the answer a lot faster, which is super cool, okay? But if you can't take the antiderivative, they resorted to Riemann sums. We resort to our calculator, which is doing what? Riemann sums, okay? All right, so anyway, product rule. So I'm gonna go first, times derivative of the second, plus the second, times derivative of the first. I'm gonna go in and do this one so I won't forget about it. 1 minus x squared to the negative 1/2 times negative 2x. The derivative of arcsine is 1 over the square root of 1 minus x squared. And the derivative of x is 1. So this is first times derivative of the second plus second times derivative of the first. And so now I'm gonna, this is y prime. Sorry, that's real important, y prime. So here I have x over the square root of 1 minus x squared. Don't forget your chain rule, but the derivative of that was just 1. Plus arcsine x. These twos cancel, and the same thing happens, doesn't it? So, look at what's happened on this slide. I just took a derivative of something and I got arcsine. So later on, if I want to integrate arcsine, I got to remember that this just happened. Do y'all see I just got little bitty arcsine from my answer? So the antiderivative of arcsine is that mess up there. So do you see the chances of you remembering that ever happened to you? You almost want to start writing things down when you get something simple like tangent or arcsine. Let's go up here. And I have 2 arc cosine x. And so if I factor out those 2's, do y'all see this must be the antiderivative without the 2's? Okay, so arc cosine must be x arc cosine x minus the square root of 1 minus x squared. Arc sine x must be x arc sine x plus there's something going on there. Do y'all see that there's a little bit of a pattern that you could memorize if you had to?
And it makes sense because usually like the cosine and the sine is just like a difference.
The
of a
different
negative.
sign, yeah, exactly. And you could memorize it if we decide that we need to. So just remember that. You know, let's try to remember that this happened on January 30th when I get around to actually teaching you these integrals, okay? Because we can look back and go, how would they have known that? Somebody had to be on the lookout for that to have ever happened to them, or they have to know some things that I'm going to teach you soon. But just remember, you know, if you had, I think now you're in a mode, I sure hope so, where you, even if you didn't notice that from where you're sitting right now, you'll start to notice, like, wait a minute, you just got, in fact, let's do it. Let's pause and take, I don't know if you've ever had this problem before. I'm going to take the derivative of y equals x ln x minus x. I think this is going to work. If it doesn't, we'll just move on. We'll just call it a good example, okay? So I'm going to say first comes derivative of the second plus the second comes derivative of the first. And the derivative of x is negative 1. Alright, so this was first times derivative of the second, plus the second times derivative of the first, and then the derivative of the tail end. Won't these all cancel out? I just took a derivative and I got logarithm. So what's the antiderivative of ln x? Some people memorize it. It's x ln x minus x. And thank God I pulled that off. But you see, I just took a derivative and I got logarithm, so that enables me to take the antiderivative one down.
That's fun.
Okay? So if you wonder, like, how in the world did you all know this? I've derived everything for you up until now. And quite honestly, there's other techniques I'll teach you to where you should be thinking, wait, what if no one ever noticed that? What if people weren't on the lookout for it enough to like make a record of it? because then you can't scale back through all your work and see that that ever happened to you. You may not have been aware that it was gonna be important one day. So there's other things out there that we'll learn. Let me move forward just on last night's homework, Euler's and derivatives of inverse trig functions. Before I do that, those two problems I think were relatively straightforward, and I heard a lot of people talking about them. Are things messing you up that you're not as polished on your chain rule when you're learning new things, or the product rule? What's messing you up? And get the answers in the back. Anything?
I would just make like small mistakes, but I feel like if I like focused more, I would.
Okay. So you understand?
Yeah.
Okay. Alright. It's really cool how a lot of these reduce. Okay, any other questions on homework? Euler's method, okay? You'll like those questions, you'll get those right. Okay. So now what I want to go to is, let's write the chart down again, just for memorization purposes. And what it does is it takes you through writing the equation of a tangent line. To write the equation of a tangent line, you need a point, and you need the slope, right? Now you're estimating, so you're counting by different increments. And what's the next box? So how do you remember that? Because you multiply these, right? Okay, so you'll fill in your point, you'll fill in your derivative, you'll know what you're what you're adding by, and then you can multiply these two together to get dy, and then you get your new point and keep moving. And hopefully all the answers matched up with what you got. So, ready to move on. All right, now look at your test. Okay. So on your test, remember, hopefully you're starting to see why I do this silly thing that you can only integrate things that are simple. Girls, listen. You have no business trying to integrate things that aren't simple. Like the only things I'll ever teach you to integrate are sine u, e to the u cubed. If it's sine cubed, you don't need to be doing that without some sort of technique. You only can undo simple things. Square root of x, yes. Square root of u, yes. Not square root of 3x minus 7, no. It has to be, are y'all with me now? If you didn't quite get that, I'm going to keep writing it. You can only ever integrate something that you've simplified on the front end. If it's a composite function or product or whatever, you can't do it unless you recognize things. On this one, you have the integral, the number 1, sine 2x, cosine 2x. So you had to let u be 2x. And du was 2 dx, 1/2. I think most everybody pulled that off. For argument's sake, just because you're not as good at the double angle identities as you should be, sine 2u is 2 sine u cosine u. You have to know these. Cosine 2u is 1 minus 2 sine squared u, or 2 cosine squared u minus 1. You have to have those memorized, but I've said that since day one. The reason that they're important is, do y'all see this composite function right here that I have written on the board over there? I can't undo a composite function unless I use substitution, but substitution is not going to get me out of this, is it? I'm going to let u be sine and d use cosine, and I can't just insert another wavy function. It'll affect the graph. I can introduce a coefficient, that's okay. It doesn't affect the pattern. And I'm always compensating for those coefficients. When I saw that, I didn't know if any of my students, which I'm very used to, I'm not pointing a finger at you, it just always happens, like I said, because of when a pre-cal student learns double angle identities, you've been going to sequences and series or something, it just does not set in your mind. So I continue to write them at least once a month, if not more than that, on the board. But when I see sine over cosine, just like you, I think tangent, because you did it so long. But when I see sine times cosine, I think sine 2u. I don't think you do. Okay? But you could have done that. I'm not a big proponent of that because substitution works so nicely here. But if I take the derivative of that, I have to use a product rule. and a chain rule, I would rather condense it into C. Alright, so follow the pattern. If u is 2x, what is if u is 2x, what is 2u? So this becomes sine 4x dx. And where would the 2 go? Because I don't see a 2 here. So wouldn't that equal 1/2? So girls, whenever I see, this is just a teaching moment. I wouldn't have done this on this problem either, but when I see this problem, I think you might need to do this and pick out your multiple choice answer, okay? Sine u cosine u is 1/2 sine 2u. Or sine 2u is twice that. Do y'all see the comparison? So if u is 3x, 2u is 6x. Sometimes that might be necessary for you to know this. So when I saw sine 2x cosine 2x, I thought, oh, that's 1/2 sine 2u. And now I could integrate sine 4x. As long as I've gone this far, let's keep going. And this is where we're headed as Calc 2 students. We're going to do this on our head, okay? Don't you ever integrate sine 4x and say it's negative cosine 4x. That means you haven't dealt with the 4, and the 4 definitely impacts the trigonometric graph, doesn't it? Okay, yeah. So you're kind of unthinking, you're in your head thinking substitution, or you're going backwards with the derivative, whichever the case may be. So Grace has already done it, okay? I know I would let u be 4x, and so du would be 4dx, and I would have a 1/4. Another way to do it, and the reason I'm pushing a few of them to do in your head is because you're going to have enough to figure out. We're going to start doing the easy ones for when I teach you integration by parts. You can move faster through that. So the antiderivative of sine is negative cosine 4x. And if I was taking the derivative, wouldn't I multiply by 4? So antiderivative, I'm going to divide by 4 or whatever you're thinking about substitution. You'll see me do that without actually doing substitution. Plus c. So this is negative cosine 4x over 8 plus c. So all I'm saying is if that had been the correct answer choice, without a lot of me reminding you about the double angle identities, you might not have noticed the real answer. Do y'all see the dilemma? All right, now, why didn't you stop me? I wanted to make that point, but it was plus, so it didn't even matter. But anyway, so now I want to continually make the point. Yeah, it was plus. Because then I looked at the answer choices and thought, no, I've never gotten any of those from what I just did. But every few weeks I plan to remind you of the double angle identities. You'll see that you have to know them. And one thing that makes me feel a little better about what I just did, I'm about to integrate this right here, sine squared x. And I think I told you this before on one of the career project things. We went to NASA in Huntsville and actually met one of the von Braun scientists that was still living. He's very old. The von Braun scientists, a lot of people aren't familiar with them from history classes. But when you hear rocket scientists, that's where it came from. They were rocket scientists, like engineers for the Germans. And they were actually our prisoners of war first, before they got immunization and became American citizens. But they were actually sequestered in Huntsville, Alabama. And they were secretly working on rockets, because we were in the rocket race with the Russians. So, have y'all heard of von Braun? That's just so scary.
Huntsville, Alabama.
There you go. Okay, well that's as close as we get. They started NASA. And I got to listen to one of the scientists, which I've heard of the von Braun scientists, so it meant something to me, but you know. He was actually integrating this, and he was talking about battery power, or I didn't know how it applied to his talk, but he was telling them about rockets, and he said I had to take an antiderivative while he's talking to my class. He's actually integrating this function, which I had just done in class. So I was really excited. Then I saw him make a mistake, and I was just holding my breath, because you never know about an AP Calc PC class if they're going to correct him or not. Nobody corrected him, but hopefully they noticed this mistake. We talked about it later. I mean, but he was talking. I just made a mistake, so I'm not pointing my finger at it. But anyway, it was just careless. So sine squared x, he said, so you know that cosine 2x is equal to 1 minus 2 sine squared x. Okay? And so it's far better to have this composite function than to have that composite function. far better. I can undo cosine 2x. I can't undo sine squared x. Here I can let u be 2x and du is 2 and I can go on with my life. Here, if I let u be sine x, I need a what? A cosine x, and I can't go on with my life. I'm stuck. You must do it this way when you see it on the AP exam or on my next test. And so I'm going to rearrange this. So I'm going to say, oh, well then 2 sine squared x equals 1 minus cosine 2x. And, use good sense. I'm going to divide them individually by 2 because one thing I hope you're learning, I had to write it on a few of your tests, divide these up into individual fractions. Integration's really good if you divide things up into individual fractions. So this is the integral of 1/2 minus cosine 2x over 2 dx. Do y'all see what I mean? I can take out sine squared if I know my double angle identities. Pause. Some of you that had Mr. Hill, and I showed it to my students in order to be and didn't make them learn it because I do it this way. But some people memorize the half angle identities, which has a square root in it. Okay? But then you square it, and so you're good to go. To me, it just makes more sense just to do this tiny bit of algebra and always depend on my double angle identities. Why do I say that some people memorize the half angle identities? Well, this is the double angle identity, but it's also the half angle identity, isn't it? Because isn't this half of that? And so to derive the half angle identities, they did this and then they square rooted if you were one of the ones that memorized it or used it. Probably an even vaguer memory than the double angle.
Yeah, it's not registering, but I
You
understand.
may have even written them on the board or put them on the test or something. It was a square root of 1 minus sine x over 2 and
Yeah.
plus or minus, okay? But I would just go from here every time. It's simple algebra, okay? Do y'all see why I chose this one? Because it has sine squared in it. I'll choose the other one if it has cosine squared in it. 2 cosine squared x minus 1. Here I would factor out the 1/2 and have 1 minus cosine 2x dx. Follow your variable. The antiderivative of 1 is x. Now watch this. What's the antiderivative of cosine? Anti is sine 2x. If I was taking the derivative, I would multiply by 2. Anti, I would divide by 2. Done. There's the antiderivative that is 100% dependent on the double angle identities. You couldn't pull it off without it. Okay? It's which composite function do you want? Alright, so I'm not going to do everything on the test. Number 2 should have been split up into 2 fractions. Number 2 should have been x squared over x, which is x, minus 1 over x, which is ln x, and then you go forward. Okay? Number 3. A lot of you got, thank you. If you integrate from 1 to x squared of a function, 1 plus t squared dt, and then they ask you to take the derivative of it, and they called it f prime of x. That's what they were asking you to do in that problem, okay? Now, remember the days that I went to Barcelona and got a bunch of stuff and carried it back in my suitcase? Do y'all remember that story? That's what this is. This is the second fundamental theorem of calculus you will be asking. Okay? I could ask it on any test as part of any problem. So why in the world would you integrate just to differentiate? However, when you were over there integrating, you picked up some things that made it heavier when you came back. But the way to do this every time is this. By the way, it comes into the last problem that people struggle with. If I tell you, I integrated f and I got g, then f must be g prime. If I say, I integrated cosine and I got sine. If you integrated something and got a function, then you just take its antiderivative. Okay, so I'll write all that down for you. So anyway, these cancel out. You do go back to where you started from. But while you were over there integrating, didn't you fill something in? F of b minus f of a? And so coming back, you've got a chain rule called up. So what I teach everybody to do, go back to where you started from. They do sort of cancel each other out. But you would have filled in the top, so on the way back, you've got a chain rule. You would have filled in the bottom, and what's the derivative of the bottom? You would have filled in 1, and the derivative of that is 0. Oh, I'm sorry, this was 1 plus t cubed?
Yeah.
So I have 1 plus t cubed, 1 plus t cubed. I fill in the top times the derivative of the top, fill in the bottom times the derivative of the bottom. Works every time. Go, I'm not gonna differentiate, I'm not gonna integrate to differentiate. I'm gonna go back to where I started from, but I understand what's happened, if that helps you. Okay? Alright, now, go with the time. Number 4, I was really proud of how you handled your logarithm rules there. And so I didn't really know how well that was gonna go. So on this one, you have the interval from 2 to 3 of x over x squared plus 1 dx. Way too complicated to pull off. Most of y'all saw right away, let u be x squared plus 1. Du is 2x dx. I have an x dx. So I have 1/2 du equals x dx. You need to be excellent at substitution like in your sleep, because we're moving on, okay? Now I change my limits of integration. When x is 2, u is 5. When x is 3, u is 10. Most of y'all changed yours also. And I get 1/2 u du. So I have 1 over x squared plus 1. X dx is 1/2 du. Don't go back to your x's. This is ln u from 5 to 10. So I have 1/2 times ln 10 minus ln 6. Those are both positive. Oh, that's a 5, sorry. And then you look at your answer choices and there's enough there. ln x minus ln y is ln x over y. So this was 1/2 ln of 10 over 5.
I was like, oh, that one equals that.
And so you got 1/2 ln 2. Some of you should be as proud as you had your calculators during this time, so you could have figured it out from your integration where you got down as far as 1/2 ln 10 minus ln 5. But these be non-calculator problems, which again you're subject to with me on any quiz and any test. So remember, if logarithms are divided like ln a over b, it's ln a minus ln b. If logarithms are added like ln xy, it's ln x plus ln y. If you have a number up here, you can pull it down. If you have a number in the front, I can pull it up. I can move all of that around. Okay, so if you'll somebody will just mark that, I'll mark it on mine. We're gonna stop there, even though I know you have more questions on the test. And we may or may not come back to it today, but I'll continue to pull it in, okay? Now, I know that Grace and some other people probably have some questions on the 2003 exam, the free responses. Is that what you've been trying to ask?
Yeah.
Let me go ahead and show you what you do for homework. And then if I have time, I'll answer 2003 questions. But I just carry that in my syllabus until that's done. You're about to get a BC exam. I probably won't give you the 2003 BC, because so much of it's like the AB. But I'll most likely will give you 2008, and we're going to start looking at BC exams. And we'll do it piecemeal, we'll just get it done, and then you'll have 3 or 4 of them done. I want to say that real quickly, now that we're in January, almost February. I'm not a big fan of, with all the material that I give you, of going out and buying a prep book for AP Cal, which you probably already maybe have sitting on your desk at home, if you have a desk at home. But anyway, if you're gonna get one, or borrow one, or buy a used one, or your friend gave you one, strongly recommend the Princeton Review, okay? I strongly do not recommend the Barron's, or some that offer practice AP exams. I wouldn't go that route. They'll make you practice things you don't need to, that you'd be spinning your wheels, some of them are wrong. Depend on AP. And so having said that, by the time you face the AP exam, you will have worked at least 4, if not more, full-length BC exams under my structured guidance, okay? And it'll be all old AP stuff. Everything I do in our book, you notice, is an AP edition. So since I'm so old and done it for so long, I'm well immersed in it, and I just don't want you wasting your time, okay? I mean, it doesn't hurt me either way, if you have a study book. But I wouldn't go buy one of those Lynn Barnes and Noble, like the best AP, study guide guarantee of 5 4.5. Unless you see great reviews for it, you really want it, but I'm gonna give you plenty myself. You'll have lots and lots of practice, so don't go buy something that gives you AP practice if I'm gonna provide it to you for free. But if you're gonna do one, I recommend Princeton, okay? And it's good, and you might need that. You might need to go, oh, I need to brush up on some things, and, you know, you can do it instead of asking me, but, anyway, so that's just that. Any questions about that? So also, I wanted just to say a tiny thing about, you know, what's happening to you. Maybe you should go visit college classes, and you feel good about what you're seeing. It's another, just if you make a 4 or 5 on the BC, please, if your college lets you, please go in and take your credit. I ran into a Marymount girl last night that's graduated. She's working on the GW Bridge with an engineering firm. She made, I don't remember, 4 or 5 on the AP Cal BC exam, and she got a job right out, you know, Lillian Kennedy's another one, that they get a job right out, they went straight into multivariable calculus. Take your credit if they give it to you, because you don't want to sit back through derivatives and integrals. It's not gonna help your GPA. I mean, if that one class is gonna help your GPA that much, I don't know what's happening in your other classes. Like, I just don't think that one class is gonna, I don't know, that's really stupid of me to say, because my GPA ended up being, if I ever told you what it was.
Oh, you totally, was it like you missed it, but like,
And he did it.
you barely graduated.
That would have been my dad.
Did you be like?
And undergrad, and graduate school is 3.9, 3 or 4.
Did you have to get like?
Oh, yeah, you had to have 3.9 to graduate summa cum laude. They called out my name, magna cum laude. I'm like, what? I've spent 4 years trying to graduate summa cum laude because I'm obsessive about my grades. That's why I didn't get your grades so fast, because I'm obsessive about my grades. And I sat there going, seriously? I just knew they were gonna say, you know, Becky Johnston, summa cum laude. After 4 years of work, somebody my senior year gave me a B that I didn't even see coming. And nobody's rounding that up. Yeah. So, to say that one class won't hurt your GPA, that's sort of like a stupid thing for me to say. But anyway.
That's so annoying.
Yeah. So,
I would be so mad.
oh, if you knew the whole,
Probably go beat up.
if you knew the whole story, one day I'll tell it to you. So you can learn.
You should tell us.
Well, let me go and get talking about myself later. So I want to do it again. But, when I was a senior, you go and do your like student teaching, your practice teaching, or whatever they call it. And so I went to a city called Tupelo, where Elvis was born. They have a great public school there. And so I was really excited to be, I was only an hour and a half away from campus at that for 45 minutes. So I could still go back to Ole Miss for parties. Anyway, so I got this great student teaching job at a great high school. But after a couple of weeks there, and I was 21. But after a couple of weeks there, they had actively been looking for a maternity leave replacement for a teacher named Miss Llewellyn, who was 8 and 7/8 pregnant, 8 months and 7. She was 9 months pregnant, and they still hadn't found a replacement. So they're like, well, you're here and you like you're doing a good job, so we want to hire you to teach. So I didn't have anybody over me in my student teaching. I was the teacher. I asked a lot of questions from my mentors, which were great. But they had to get special permission from the University of Mississippi for me to get paid to actually be a teacher, because they had not done that before. So I'm like, all right, wonderful. Like, they want me to be a teacher. Granted, they were desperate, but put that aside. They hired me to teach as a student teacher before I ever graduated. And so I had this professor named Dr. Truax, who part of our grade was to be at the like 10:30 meetings on campus once a week or once every 2 weeks. Well, I was teaching, I couldn't be there or 45 minutes away, so I just didn't go. But he was in on giving me permission because he was my advisor in college. That was the B that made me have a 3.8 now. He gave me a B. I called him and like, why did you give me a B? I've known you for 4 years. I made A's in all your classes. You're my advisor. He gave me permission because you didn't attend it as a blanket. You have absences, and
What?
I give you a B. So I hung up the phone crying and went on. might as well not even try it, I might as well just have a 3.75.
Exactly.
That's what I think.
That is not a good life lesson. That is not a good life lesson. Okay, so now what we're gonna do is we are going to integrate this. Dx over the square root of 4 minus x squared. I prefer for my students to write it like this because something happens when you see the 1 over, okay? Girls, if I put that on your test, you all would have tried 4 minus x squared and then you'd have been stuck, right? Because what would you need? Negative 2x dx? Can you see that without me writing it down? You would have been able to do it, so it would have been really rude of me to put it on there until now. Now do you recognize it that it's sort of like an arc sine problem? You've only done one right homework on it. And I've only talked about
That's exactly what I was thinking.
Okay, so let me say this now that I pointed it out, does it look like? Okay, the derivative of arc sine, is 1 over the square root of 1 minus u squared du. So now you can start to recognize maybe to go backwards, which is what we're gonna do. All right, so let me write how to go backwards. All right, so, and your homework will be on this. All right, so,
He's like in the corner, like.
I thought it was really cute. Okay. If you have 1 over the square root of a squared minus u squared du, that equals arc sine u over a plus c. Okay? So let me show you why first. Let's do one. If last night's homework had been arc sine of 2x over 3, okay?
Could you go back up really one second?
I'm going to go back.
Okay.
Just a second. Because I'm going to fill in 2 more.
Okay.
Okay, so you'll see it, Carla. Pause. Everybody pause. Okay, pause. But be quiet while you're pausing. Okay, so I'm going to take this derivative like last night's homework. Okay, but a little bit harder. So I'm going to say 1 over the square root of 1 minus u squared du to take the derivative of that. So you need to be memorizing the derivatives, okay? So 1 over 1 minus u squared, and the derivative of u is 2/3. So this gives me 2 on the top and a 3 on the bottom. Okay, that's 3's down there with those. Now that gives me the square root of 1 minus 4x squared over 9. You wouldn't leave it that way. What would you do next? Girls, if you ever have 2 fractions, what do you always do?
Oh,
Common denominator, okay?
More or less like.
So this is like 9 over 9. So I have 2 over 3 square root of 9 minus 4x squared over 9. So I have 2 over 3. In fact, this is going to be gone. Can y'all foresee that?
Yeah.
This is going to be the square root. Okay? Because what's the square root of 9? 3. And those will cancel out. So I wanted to do one where I took a derivative and there's not a 1 right there. I think maybe all your derivatives last night, you went 1 over the square root of 1 minus u squared du. But there are times that you can have a fraction, and since you have a fraction, other squares can pop up in there. But y'all see where this 3 was? Became a 9 there. This 2x became that squared. And so that's how they got this pattern that I'm showing you. Okay? So it didn't just happen then, but sometimes when I'm teaching this, all of a sudden they're like, wait, the tiny bit of arc sine homework I've done is always 1 minus x squared on the bottom. But y'all see where that number could come from if you have a fraction. But if you don't have a fraction, technically 7 is a fraction, but y'all know what I mean by that, right? If your denominator is 1, then it's going to be normal looking to you, okay? Now, if I have the integral of 1 over a squared plus u squared du, can anybody guess what that one's going to do? Almost. Which tan? Because tan was the one without the square root. Okay? Now it's 1 over a arc tan of u over a plus c. You could justifiably ask, what's the 1 over a doing in front of there, but it's just if I went back to the other slide and took a derivative, you'd see it crops up in the tan, but not the sine. And then we have secant 1 over the absolute value of u, square root of a squared minus, I'm sorry, u squared minus a squared.
Are you okay?
du is 1 over a
You won't do like a weak recipe change. You're just like slightly.
1 over a arc secant of u over a plus c. You know what, in our book, oh yeah, they did, okay. You remember how the absolute value, like I'm asking a lot, I know, since I teach so fast, but in your tiny bit of experience with arc secant, it's got the absolute value outside the outside the square root. Actually, girls, that absolute value in your derivative formula that I gave you Tuesday, I didn't derive it for you, which I said I wouldn't be doing much this semester. I already set the stage for that, but it came from there was a u squared under the square root. So when you pull it out, that's why the absolute value is there. So going backwards, you need to put it back. Okay, there's 3. What's missing? Carla's already said it. Where's the other 3? And why wouldn't they give them to me?
Where are they?
You know what? Girls, if I have negative of this, I'm going to pull the negative to the outside. Do you see I don't need the other 3? This is all you need. If I have negative 1 over a squared minus u squared, I'm just going to pull the negatives to the outside and have that. So good news, you only have 3 of them, okay? So let me do an example. Sometimes you can just piece it together, but we'll write it down. All right, so I'll come back to this. So that's that slide. All of these are in your book also. All right, so I'm going to integrate 1 over the square root of 4 minus x squared dx. All right, if you have the integral of 1 over the square root of u squared minus a squared du, it's going to be arc sine of u over a plus c. Arc sine's the only one of 3 that doesn't have a 1 over a in front of it. Did I put a 1 over a in front of the arc secant? I should have if I didn't. Did I? Yeah. Okay. Arc secant and arc tangent have a 1 over a in front of it because that's what happens when you take a derivative. So I'm going to move on. You're just going to have to trust the process. Now, I usually will make myself a note of what I have here. Like for instance, I'm sorry, I wrote this wrong. There should be a squared minus u squared. The variable's in the back of the arc sine. This one's a squared minus u squared. Sometimes you don't need to do this much work, but I would encourage you just to be careful, okay? You still might have some substitution to get this pattern. Right now, what is u? Not u squared, but what is u? X, isn't it? Okay? I think it's what Morgan meant, okay? Did y'all see that? What's being squared? U is being squared, so u must be x. What's du? 1. So everything's fine. I don't need a sub there, but eventually I might sometime. And what is a in this moment? 2. Good, not 4, right? A is 2, okay? So when you've identified it, you can go arc sine of u over a plus c. U is x, and what is a? 2. And you're done. You'll have to spend some time looking at the patterns, okay? All right, let me do another one. So I have the integral of 1 over 2 plus 9x squared dx. Okay, girls, look. Really in your book and in a lot of applications, you're going to see it this way. Something for me, I like to see it this way. So you can rewrite it if it helps you. I see now arc tan. Okay? What is u?
Negative 3x.
Just 3x, okay?
Well, I mean, it's well, I said 3x.
I know, yes, sorry. I didn't read it. So you guessed another one.
Yeah.
Girls, y'all see that 3x is being squared? If you don't do this part, you'll miss it. Because what's du? 3 dx. So you have 1/3 du equals dx. Pause. I don't know if you remember, I could scroll back to a slide. Remember there was a 1/3 in front of my derivative? Do y'all remember that? It canceled out with a square root of 9 later, but this is compensating for all of that. All right, so I gotta be super careful here, and I'm gonna set it up. Oh, by the way, what is a? What's being squared? Square root of 2. Good, Grace. All right, square root of 2. All right, so take your time. You don't have a lot of homework problems, so take your time. I want to fit it into the pattern of 1 over a squared plus u squared du is 1 over a arc tan of u over a plus c. It's one of the three that has, one of the two that has 1 over a in front of it. All right, so I've got to be really, really careful here and go slowly because I mess these up, okay? So I need a 1 over a, and so I've written all of this down. I'm not going to do too much in my head, so I have 1 over root 2. And then I run into, so I'm just filling in my pieces. That is a squared, so 2 is a squared. This is 3x squared. In fact, I'm going to go to this. I'm going to go to a squared plus u squared, and what's du, or dx? 1/3 du. So I have this extra 1/3 out here, du. So you gotta be really careful. In fact, I'm gonna take this out right now because it's really not part of the problem. And I did that very poorly, so I'm gonna do it again. I did not explain that well at all. All right, so, whoa. Did I just lose all of that? Oh, it's probably down here. Okay. Okay, everybody stop. And let me say this before I go on. This is super important. It could be that your homework problems, a couple of them, might have nothing to do with inverse trig functions. Remember what now all of a sudden it makes sense for me to say always try the other techniques first as I teach them, try them in order. See if you just know it, see if you can simplify it, see if substitution works. Don't jump at inverse trig functions or the next thing that I teach or the next thing that I teach, okay? Try it in order. I would try and think in my head, oh wait, what if u was just 2 plus 9x squared and I had like an x in there that I could compensate for and I could move forward? You've seen problems that look like this before. They just had other things in them to where sub worked. So try those first, please, okay? It might be that substitution works, but it won't work here. So then I would identify u, I would identify a, and then I would rewrite it. This is the integral of 1 over a squared plus u squared, and if u is 3x, then dx is 1/3 du. So what did I do here is I took out dx and I put in 1/3 du, and I have 1 over a squared plus u squared, and now I'm ready for my pattern. So I already have this 1/3 here. Then my pattern tells me 1 over a arc tan of u over a. U is identified 3x over a, which is square root of 2 plus c. You can leave your square root in the bottom. And that would be your answer. Okay, so now let's do this one. I'm just going to keep doing examples. All right, so this one I have the integral of 1 over x square root of 4x squared minus 9 dx. The dx was actually on top of it. Girls, if this problem said this, it would be a substitution problem. Don't just go straight to inverse trig. Go through, y'all see sub would work here? I'll put that u be 4x squared minus 9. Du would be 8x dx. I could compensate for the x dx. So they're very similar. This one's sub, that one won't work with sub. So now hopefully you'll notice you maybe have some sort of arc secant going on because of this u business here, okay? The formula for arc secant is the integral of 1 over u times the square root of u squared minus a squared du is equal to 1 over a arc secant u over a plus c. You've got to memorize that. But now I think that that's it because it looks a lot like that, but I've got to identify everything really slowly, okay? So, all right, so what do you think u is? All right, what do you think u? Oh wait, u's a variable, a's a number. U is 2x. Okay? And what is du? Wait, no. Du is 2 dx. So I have 1/2 du equals dx. Y'all see I have a little bit of substitution in here. I'm not letting you be the whole thing. All right, what do you think a is? Somebody's already said it. 3. All right, so now let's see if I can get this pattern right here. All right, and just ignore the stray marks. And please hold still, girls. Watch me fit this together. Oh, I'm sorry, I guess some of y'all were talking about the problem. All right, this is the integral of 1 over. I have the square root. That is u squared. This is a squared. Dx is 1/2 du. But what am I going to do with that? What is x? It's 1/2 of u, isn't it? So I'm going to write this as u over 2. Okay? So now, let me move this down. So I have to be really careful with this because I almost have this pattern right. I almost have this pattern right here. I want that u to be there all by itself. So couldn't I multiply the top by 2 and the bottom by 2? All right, so I'm going to multiply the top by 2 and the bottom by 2, and that cancels. Now where can I put that 2? Outside, which gets rid of the other 2.
Right.
So now I have the integral of 1 over u square root of u squared minus a squared du. And I'm glad for notes that I've written to myself. So I have 1 over a was 3, arc secant u over a plus c, and u was 2x. So you have a few to do, but I think we all agree it takes some doing. The examples in the book are great, and so you can look at those. I'm sorry, I was just glancing to make sure I did those.
the formulas on?
The formulas are on page 382 and your study guide, okay? And please keep bringing your 2003 exam and your test to class, and we'll just keep doing all of that review. Questions?
Earlier when you were like listing all of the ones, you put 1 over u. You put 1 over u times the square root of u squared times
Did you spell that?
like if you're listing like the times
Oh,
Take a lunch.
like that?
yeah.